Welcome to the Design Day video of Team 23088. Our project is titled Supplement Recommending Mobile App with Handheld Measuring Device for Saliva pH and Calcium Values. Our project is sponsored by Dr. Larry Head and our mentor is Dr. Elmer Grubbs. My name is Raphael Leperk. I'm the System Lead and Project Advisor.
Hi, I'm Elliot Zerker and I'm the Team Lead.
Hi, I'm Annette Garcia and I'm the Biomedical Lead.
I'm Nathan Hurling and I'm the Procurement Lead.
Hi, my name's Keegan Godfrey and I'm the Software Lead.
Our project is a bit unique because I was able to submit our own senior design project idea. This entailed a dual enrollment for me in the engineering capstone, but also the new venture development program from the McGuire Center for Entrepreneurship. What this meant for us engineers was that the design requirement changed throughout the program and that our minimum viable products were presented at various business events so we could collect valuable user feedback. The purpose of my startup company is to provide tools and services that will allow my future customers to shift their focus from reactive treatments such as blood pressure medication and insulin to more proactive remedies such as lifestyle changes and nutritional supplements. This is accomplished through the ability of our systems to detect the early development of certain illnesses. The first system that does this is our prototype for a saliva testing medical device that will test your saliva for a healthy pH and calcium range. We also developed an algorithm that analyzes your blood work, which you would get from a lab, and then finds which deficiencies you might be developing. Lastly, we worked on a machine learning back-end process that evaluates all the collected user data and improves our processes and recommendations. These products will not only help those that are already interested in alternative health, but also the people who don't have access to qualitative medical care in the US and even abroad.
One of our major system requirements was to build a handheld device that would be capable of measuring and reporting the calcium concentration and pH value of a user's saliva. Numerous dentistry journals have identified a positive correlation between salivary calcium and protection from tooth decay. It is also common knowledge in the dentistry world that good saliva is naturally buffered to a neutral pH to avoid tooth decay and periodontal disease. By allowing users to collect and record their own salivary biometric data, our device will help them address potential calcium deficiencies in their diet as well as monitor their salivary pH. We also established a system requirement that the handheld device should be able to pair with the mobile app via Bluetooth so that users can log their saliva tests alongside their blood test results. The core functionality of the mobile app addresses the system requirement to build an algorithm that identifies deficiencies within the user's blood test values and correlates them to supplements intended to improve these deficiencies. Finally, the website consists of 3 requirements. The requirements are content, AI, and commerce. The website has a functional questionnaire that utilizes supervised and unsupervised learning to better tailor supplement recommendations on third-party sites. The website also serves to advertise the company's mobile app and handheld device.
When it came to the handheld device, our research focused around selecting an electronic method for measuring calcium and hydrogen ions. Our research eventually converged on the technology of using ion-selective electrodes, which operates around the principle of measuring a voltage between a reference electrode and a working electrode. We performed a trait study for the handheld device to determine the most user-friendly option for interacting with the electrodes and taking saliva measurements. We quickly identified the biggest risk with the handheld device would be designing our own sensor interface circuit that complies with our form factor requirements and ISO 10993, which is a standard for biological evaluation of medical devices. For the mobile app, one of the main risks was being able to establish the links between blood values and illnesses. In order to understand the blood chemistry behind the mobile application and provide valuable insights, we turned to the medical publication, one of our main sources being the book Blood Chemistry and CBC Analysis by Dr. Dickon Withenby. This book provided detailed information and optimal ranges for different markers and how they relate to various health conditions. By understanding these optimal ranges, the mobile app algorithm can identify potential deficiencies. For example, low iron levels can lead to anemia, while low magnesium can cause muscle cramps and weaknesses. After identifying these health conditions, we used another valuable resource, Prescription for Natural Healing book by Phyllis Balch. This book provides detailed information for natural remedies and supplements that can aid in addressing common health conditions. The identified risk for the website was the novelty of the idea itself, that is combining machine learning with a website questionnaire. The risk was mitigated by employing stepwise development of the algorithm and through the use of Python libraries such as NumPy, SciPy, and scikit-learn.
The ion-selective electrodes of the handheld device feature a linear relationship between voltage and ion concentration. Our custom interface circuit captures this relationship via an analog to digital converter, or ADC, Before any hardware started to arrive or any prototypes began assembly, we analyzed the technical specifications of the datasheets of these devices to develop circuit models and perform preliminary analyses to verify our design concept. Between the slope of the ion voltage curve and the necessary device precision laid out in our system requirements, we were able to calculate the necessary signal gain and resolution of our ADC to build our circuit. Our calculations gave us a margin of 0.003 milligrams per liter to achieve 1 decimal precision.
All schematic capture and PCB layout for the handheld device was done with KiCad. We were correct to identify the interface circuit for the ion selective electrodes as a major risk for the handheld device. The rest of the system is much like a microcontroller project that students would build in a junior or senior level electrical engineering class, consisting primarily of buttons, an OLED display, and various other simple inputs and outputs. The interface circuit, however, is a specialized analog signal conditioning chain, the design of which required plumbing the depths of component datasheets. Our biggest challenge arose due to the fact that electrodes are high impedance sensors, which require a very specialized class of ultra-low input bias current amplifiers to interface. Choosing an amplifier that would meet this stringent requirement and integrate with the rest of the system required hours of research and multiple prototypes to complete. To keep the project on schedule, we chose to develop the interface circuit as a separate daughter board that could be soldered to the motherboard once it had been tested and verified. The mobile application was put together using Xcode. The ISO standard employed was 12207. This standard covers software lifecycle processes. It was applied to the application in order to establish a consistent development environment across the mobile team. This included well-documented code, consistent structuring of variables and functions, and version control of the application. The application includes a supplement recommendation algorithm, a Bluetooth connection with the handheld device, a map feature to locate nearby labs, and a computer vision page to scan blood test documents. The most challenging aspect of this implementation was integrating all functions together in a cohesive fashion. This challenge was overcome by bringing a demo version of the app to someone who had never used it before. They were instructed to attempt navigation through the app without any prompting. Afterwards, they were asked on their thoughts for navigating the app. Their feedback was then taken into account and design adjustments were made accordingly. The website was designed using ISO standard 23026. This standard was used to define and manage the requirements for the life cycle of the website, including strategy, design, engineering, testing, and validation. The design of the questionnaire, which shall be displayed on the company website, kasunmi.com, required handling of the integration of MySQL, JavaScript, PHP, Python, HTML, and CSS. Software development took place within Eclipse, an IDE for Java and Internet applications, and IDLE, an IDE for Python development. XAMPP was used as a local server. The entire website was built from scratch with the final deliverable meant to be a beta test for the to-market version. There was no blueprint for this project, and the idea of integrating machine learning with the questionnaire is a new one. Therefore, the biggest challenges were development of the environment itself and the novelty of the questionnaire. These challenges were overcome with a mix of iterative development, design boards, and writing of smaller programs to test ideas under construction. The ISO standard applied also required the utilization of an ever-evolving suite of unit tests.
To summarize, we were able to develop a functional prototype of the Saliva testing device that accurately measures pH and calcium levels in the tested liquid. We finished the mobile app with a functional blood value interpreter that now accurately determines which illnesses the user is developing and which supplements they need to replenish their deficiencies. Finally, we built a prototype for a machine learning backend process that can be applied to all sorts of medical data collection applications.